Alright, welcome back to Meteorology 101. I'm going to try to keep this video short. We're just going to touch the synoptic situation, and got some thunderstorms going on down in Texas. Snow to the northwest, I think a little snow to the northeast. So let's pull up the surface plots. Let's get an idea of what we're looking at and go from there. Okay, so looking through northern Texas, looks like we have rain being reported, and ceilings right around 2,400, 2,600 feet, just below 3,000 feet. That's why we see the marginal VFR conditions. To the south, we see IFR conditions, and there's ceilings at 600 feet, 800 feet, visibility 4 to 6 miles with mist. Looks like a cloud cover all through the south central United States, over the northwest, and then over the Great Lakes region. So we're looking at northerly winds out of the northern Texas, a little bit of southerly winds, onshore flow off the Gulf of Mexico. We got the warm, moist air being pushed north, and then looks like maybe a frontal boundary, the stationary front, where that dissipating cold front is pushing along the Gulf states. So that's causing our lift and giving us these thunderstorms in northern Texas right now. A couple lightning strikes over in southern Arkansas, northern Louisiana. So let's pull our pressure. See where our highs and lows are. Got a high pressure over the Ohio Valley tri-state area, centered over that. Still looks like broken cloud cover, winds out of the north at 10 miles per hour, or 10 knots. And maybe some lake effect snow up in Canada, and a lot of cloud cover over the Great Lakes region. And then onshore flow over the northwest. We'll pull a thickness chart. We'll see where our 540 line is. Looks like snowfall to the northwest also. Maybe some rain along the coast. And then once you get into the upper elevations, then we'll get some snowfall. So it looks like this one station is reporting a ceiling at 2,400 feet. So we're a marginal VFR there. Marginal VFR is 1,000 ceilings, or between 1,000 and 3,000 feet, and or visibility 3 to 5 miles. So we do got some significant winds, 40 knots, pushing from the southwest of Montana, 30 knots over Wyoming. So we do have a little bit of winds going on. Probably some gusts associated with that too. Looks like low pressure located over Mexico, troughing up into the Four Corners area, and then high pressure off the west coast, ridging into over Nevada and northern Utah, over the that plateau area. It's usually a plateau high, hangs around in that area. We could probably put a little high pressure system there, depending on the rotation of these winds. And then that low pressure system moved well off to the northeast. That front undergoing frontogenesis, wrapping around this high pressure system to the south, and then coming along the Gulf Coast. We could throw the fronts on just to get an idea of what we're looking at there. Probably going to clutter us with highs and lows. The computer generation tends to do that. It looks like troughing all along the lee side of the mountains. There's that cold front over the Atlantic coming into South Carolina, Georgia, and then becoming stationary over the Gulf Coast. And then any warm, moist air, throw our temperature lines on here, warm, moist air from the south lifting over that frontal system, that frontal boundary right there. That's going to cause our lift and any precip we have over Texas. So let's go look at a radar real quick. Look at a national radar. And you can definitely see that there is quite a bit of rain showers over Texas, Louisiana, Arkansas, all the way up into Missouri. Significant snowfall up in the northwest. So rain showers along the coast, onshore flow, and then once the elevations hit that freezing level, you can see where the snow line starts, and then pushing into the mountains area into Idaho and western Montana. You can see all that snow and some of it mixed with rain. So, and then like I said, snowfall over the Great Lakes region looks like a lot of lake effect snow, and then over Buffalo, upstate New York, some snowfall, and then well off the northeast of Maine. So we're gonna look at these thunderstorms. Let's pull a vorticity chart. We'll see what kind of vorticity we have in this area. They're looking for the National Weather Service has a area of marginal risk for severe thunderstorms over the Gulf states for I believe tomorrow. So we'll see how that all pans out, and maybe we'll pull some upper air data and see how this system's developing and what's going on there. Let's get back to our charts. Okay, so like we said, we have that lift. We have troughing off the east coast of Florida, troughing on the east side of the mountains, that plateau high over Nevada, low pressure to the south. So let's go up to the 850 and just get an idea there. Real quick before we leave this surface, let's go ahead and pull a thickness chart. Let me get rid of this. We can look at the lapse rates too down in Texas, see what kind of lapse rates we have, the temperature decrease, the rates they decrease with height. That'll give us an idea on those thunderstorms too. There are no active warnings at this time for severe weather. There was some potential, about 60% potential on some hail, severe hail development, maybe some gusts, wind gusts from the thunderstorms from the downdraft, but really no warnings have been set. So this thickness chart usually takes a minute to build. Got a lot of data it's got to process. So we'll look at vorticity, lapse rates, and then see any kind of moisture. We'll pull up the upper levels and see what kind of moisture associated with that system in the Gulf or over Texas. So we see our 540 line, the purple dashed line, coming through northern Kentucky, Virginia, Kentucky, Illinois, shooting up, wrapping around. Looks like maybe a warm core area, and pushing back to the south over Wyoming into northern Utah, Nevada, and then off the coast over Oregon. So anything to the north of that would be snow, except you have that looks like rain showers or rain off the west coast. You get that warm, moist air raising that freezing level high enough where you're going to just get rain. So you can have some modifications there. Along this line should be mixture, but that can always change based on other conditions. The freezing levels are very important. If you have a warm layer aloft, one single freezing layer, and how thick that is, or two freezing levels, and how thick that warm layer is aloft also, causing different types of precipitation. So we can see we got IFR conditions to the south. Onshore flow 25 knots, 10 knots, 5 knots, light winds causing that mist, 6 miles, 4 miles visibility, and then some warm air advection. You see the warmer, that's a 500 millibar thickness, so that's your thickness lines to 1,500 millibars. So one thing you get out of this is the thickness lines. You can look at the jet stream. Looks like we have pretty much there's a little troughing across the United States, but it's a predominantly west to east flow with that jet stream. No significant troughs or anything like that. So we can pull up to 300 or 250 millibar, get a good look at the jet stream if we want, see if there's any subtropical jet forming down here, or another finger of the jet to the south. So there's our 540 line, thickness lines, and we can still have our surface plot so we can see where those IFR and marginal VFR conditions are. Alright, let's go up to the 850 real quick. Let's run a moisture. See where our moisture layers are. This is at 5,000 feet. We do have significant moisture along the Gulf states. So we do have 5,000 moisture at 5,000 feet. Moisture over the Great Lakes region and over the northwest. Let's pull our pressure. Okay, so we got the high pressure system to the south, and the rotation around the high is clockwise, so that's pushing all onshore flow at 5,000 feet. Still showing that little bit of a low pressure system over New Mexico, almost becoming closed. So we have to keep an eye on that. Significant troughing all on the lee side of the mountain, so that supports all that troughing that was on the lee side on the surface also. So we're ridging in the upper levels, troughing in the upper level. This is just still low level. We're still only 5,000 feet, so still got that ridging coming onshore from the Pacific all the way over to Utah. Let's look at our station plots, and then we throw some temperature lines on here too. We should see some advection in these areas. So warm air advection with the high pressure system, winds out of the south. 20 knots, 20 knots, 10 knots. So our dew point depressions are less than 5. 5 or less, that's why we have the green, all the moisture. That's a pretty saturated atmosphere. Same thing with the northwest. You got temperature advection coming in off of the northwest coast also. All right, let's shoot up to the 500 real quick. We're gonna skip the 700 for now. We can just run. Let's just run some moisture on the 700. Just see what we got there real quick. See if this is still moist in the upper levels. It's about 10,000 feet, 11,000 feet, about 10,000 feet for 700 millibar. Okay, so over Oklahoma, Kansas, we got northern Texas, we got some little bit of a moisture there. Still over the Great Lakes region, but we dried out along the Gulf states. We can pull this moisture a little bit further south than what this chart is showing. So down into Louisiana, right along that northern part of Texas. So we do that. Those thunderstorms are reaching to the upper levels with significant moisture. All right, let's just go on up to the 500 like we were. Let's run a moisture on that. About 18,000 feet. Probably still going to see a little bit of moisture here. Still got significant moisture through those Gulf states and over Texas. So let's pull station plots. We got the moisture there. Actually, moisture all the way over up into Ohio. Pull the 500 millibar heights. And our temperature. Alright, so we're becoming more barotropic in the upper levels. So we're not getting a whole lot of advection there. We need to pull a couple soundings, see what we got in those upper levels too. But we're still showing some moisture, a little bit of moisture over Utah, a little over New Mexico that the computer's not picking up. Montana, it's like a 40 knot wind. 50, 70, 75 knot wind, 70 knot wind, 70. So we got basically a 75 knot wind going into a 65 knot wind or 70 knot wind. Got a little bit of speed convergence there. So that's going to inhibit those thunderstorms just a little bit, not a lot. Get convergence, start getting convergence in the upper levels. That's where you'll get and inhibit those thunderstorms. Maybe just at least keep them from becoming severe. With the sun being down, you don't have that daytime heating. I wouldn't expect anything really severe this evening. So tomorrow, once you get into the daytime heating, then that's when you look for these storms to start building up pretty good. Let's go ahead and pull a vorticity chart. Let's see what kind of upward vertical motion we have. indication of rotation or upper level divergence. Alright, so our vorticity is well to the north. Let me let this chart finish. I want to pull the vorticity values also. Alright, so Oklahoma and Kansas, most of their positive vorticity advection. Looks like negative over Texas. This is all going to change though as the daytime heating starts for tomorrow and any of this stuff starts to move to the east. Then that's when I would look for, right in that area they have that warning or that marginal risk for severe weather. That's a pretty good place to put that. I could run another chart and we could see what kind of development we might have. It'd be development for right now, not for tomorrow. It's not a forecast chart. None of these are forecasts. These are all actual data, current data. So positive vorticity over the Great Lakes region, all the way down into Ohio, and then all over the northwest. So keep an eye on a stationary front to the south. If you see a stationary front to the south, and then you have positive vorticity move over that front, then you can get a low pressure system form up on that frontal system, and then that could move to the northeast or follow that front, or the jet stream would steer that, and then get some significant weather develop right out of nowhere, just something the models don't even pick up. So keep an eye on stuff like that, looking for any rotation over a frontal system. That's a pretty good indication of a low pressure system getting ready to form. All right, let's go run a stability chart and see what we got. We'll do those lapse rates also. We got to pull that lapse rate chart. All right, we got a couple of these stability charts. This is a advection chart. Most of our, this is some pretty strong. This one's showing pretty strong stuff up to the north over the Great Lakes region. That's right. Must be a low pressure system up there. We have to check that out. Off the northwest, off the east coast, really we got a little bit to the south. So as this moves over these Gulf states, I mean, yeah, you can still have a, I guess they could call it a marginal risk, but I'd say it's pretty light. But like I said, this is actual data versus forecast data. So the forecast data, as the daytime heating takes place, this could intensify and become even more unstable. So pretty good call just to say it's a marginal risk along the Gulf states. Let me pull up another one. This chart actually, it gets a little intense sometimes. It's same chart but a little bit stronger on that data. So like I said, same chart, a little bit darker colors and a little more intense on the instability. So kind of take that one with a grain of salt. It kind of does a little overkill on that. We'll do one more with the lapse rates. So the standard lapse rate, temperature decreases with height about 6.5 degrees Celsius per 1,000 feet, 1,000 meters. Once you get into 7 or 8, get up to the 8, 9 area, that's where you start getting some pretty good instability. So right here's a 7, here's an 8, 6 is standard. So 6, 6.5 standard, 7. You have, northern Texas is where it's still in the 6s there. Well, as this moves to the northeast, that changes. So you get into that 7, 8 area. As this lapse rate, the air mass modifies and moves, then this lapse rate will move with it and still modify with it also. So you get up into that 8 area, then you'll get into those possibility of a little bit more severe thunderstorms. So I do have a bunch of other stability charts we can run. Let's go look at them real quick and see what we got. Let's see what comes up for we're getting into the severe weather season, so we need to start using these charts and getting used to them. So this is a total totals. It's a stability index. I'll get all the definitions as we start going into the season on this stuff. I don't remember it all from the top of my head. It's all plotted from SCU-T charts, upper level data, and determines the stability of the atmosphere based on humidities, winds, the wind directions varying or backing with height. So we can still see we got a pretty good, we got 40 to 48. We're getting more unstable in the east part of Texas, so we do got that instability down there. And like I said, as that moves along with these wind patterns here and starts moving over the Alabama, Mississippi area, and you get that daytime heating along with that, that becomes even more unstable. So now we're looking at a pretty good call on that marginal risk. Let's go find another one. We got a lot of charts in here. Let me see. Looking for maybe like a lifting index, an LI. I don't know if I have one of those. I don't have anything on Cape. There's just an instability index. I'm not sure what that one was. There's a lot of script that was written. I downloaded for this program. Some of it I modified to make more accurate. Some of it just is totally off the wall and useless. So a little bit of an area over northern Texas, so that's accurate for the data now. So you know, as these stability indexes do pop up, and like I said, with the daytime heating becoming even more unstable. All right, so we go with the National Weather Service's call on a marginal risk over the Gulf states. Is that warm, moist air, that maritime tropical air, is pushed onshore over that stationary front, giving it the lift, becoming unstable. That's a pretty good indication of thunderstorms for sure, and there's always that possibility for severe thunderstorms. All right, so let's see where we go. Let's go look at the jet stream. Let's go up to the 250 for now, and then we'll pull the jet. Get an idea where our jet stream is. All right, this is pretty strong winds all over the United States. There's really, we got a jet max right through the plains. So with the high pressure to the south and the ridging, it's ridging all the way up into the upper levels. That jet max going around that ridging. Jet max coming on shore. Let's see what we got. Let's pull up some pressure. Throw some more data on here. Let's get an idea of what the flow is. We'll throw some streamlines on this thing too. There's high pressure actually trying to close off up in the upper levels. That is hard to see. Still got some weak thermal advection off the northeast with a jet max. So if we find any weather pops up there, I think that's where that one chart was showing us a pretty strong area of instability off the east coast. So as a jet stream shoots over a low pressure system, it just can create a vacuum and suck the mass out of that low pressure system and cause it to intensify. So maybe that's what that chart was picking up. Let's go to let's throw some streamlines on, and then we can throw our station plots, get an idea what these wind speeds are. streamlines are going to give us our flow. Just say, where is this jet stream actually flowing? And you can see a little bit of ridging, troughing, and then pretty much directly across, right over that high pressure system, and then right off the east coast. So that's an idea where your jet is. Let me get rid of that one, and then we can put the station plots on. Alright, so now we're looking at 100, 130 knot winds, 150 in the jet max, maybe 160, 165 knots, 130 over there off Connecticut, so over Connecticut. So that's pretty strong winds right there. And we do have jet, with these thunderstorms, we have these stronger winds in the upper levels up to 100 knots. Is that them thunderstorms move to the east, and if we maintain this jet stream, then we can have a little bit of upper level divergence caused by speed divergence in the upper levels, and causing those thunderstorms to intensify. But just high pressure system, I don't know if that's 100% accurate the way this is plotted, but get ridging in the upper levels, that's going to pretty much stop all the major development for severe weather. So, but that's a little to the east, and I'd probably going to continue to move along with the jet flow. So this is an area of troughing into that high, and then so over Tennessee, anything up in the northern part of these Gulf states, that's any of those thunderstorms that develop with that troughing right there in the upper levels, then you got the instability you need in the upper levels to continue for those systems to develop. So, all right, let's go to. We can go to the models real quick. I don't want to keep this video too long, but here, let's go to the models real quick and let's see what we're working with. Okay, so I'm already way out on this one. Let me go back to the beginning. It's got the rain showers over Texas, all the way into Alabama. Right now we're showing rain showers all the way into Mississippi, maybe some isolated stuff in Alabama on the radar. But let's go forward from here. Now it gets to jump, pretty significant jump. This is valid. This is 0Z Friday, 7 o'clock this evening, so it's about an hour and a half behind. 1 o'clock in the morning, developing a little bit stronger, and looks like over Arkansas getting the strongest convection, and then still over Arkansas and northern Mississippi, Alabama, maybe mainly Mississippi on that. And then starts pushing to the east, and that is by 18Z, 1 o'clock in the afternoon, and that becomes pretty intense on that line. And that's where they have their marginal area for severe thunderstorms, and then pushes off up to the northeast, gets across the mountain range, pretty much dissipates most of that, and then just remains some rain showers. And then the rain pushing up on the west side of the mountains, becoming convective over Tennessee, and then hitting the mountains again and pretty much dying out again. So, and then we got another line coming back through, and that starts with rain. Looks like rain showers over northern Texas into Arkansas, and then becoming convective again. And this is at 06. It's 1 o'clock in the morning on Sunday, and then that's pushing into southern Missouri, Illinois, Indiana, and then becomes pretty strong over Kentucky. So we'll have to keep an eye on that and see if they're going to go for anything that's going to be severe over Kentucky. Let's get we could do a cross section on that real quick and see what we're working with on the, if we could determine the severity of that thunderstorm or that line. So we do have an area of positive vorticity right about the 500 millibar level. Pretty strong over that area that's pretty close to the center between the A and B. It's right over that line, so definitely positive vorticity. Let's see, I don't see anything real significant here that's pushing any major rotation, except for that vorticity, and it's not real super red. So you get up at these, like this upper level, you know, you get into that red area. That's what I'd like to see in that lower. Once you get about basically down to the 700, you start getting into the 700 to 500 millibar on a real strong vorticity. Then I would look for, you know, a major potential for that being a severe. They'll probably go marginal on that anyway. We'll have to pull up the charts for the next few days, see what they're predicting on this. So this is on a Sunday, so we'd have to go maybe 3 days out and see what we're looking at there. So we'll keep an eye on their systems. Stay tuned, and we'll have more videos coming. So I want to say thanks for watching. Please subscribe to my channel. Visit meteorology101.com. Get your head in the clouds, and we'll see you next time.